Alright, in this video I'm going to be doing an introduction on how we plot equations on the plane using ordered pairs. So the way that an equation is going to look is that like y equals something. So for example, if I had like y is equal to 5x plus 1, what this does is it gives us a relationship between the x and y coordinates on the plane. So if I plug in a point for x here, let's just say that I want x to equal 1. Well, then I can get a corresponding y value when I evaluate this expression by plugging in 1 for x here. So I'll have a y is equal to 5 times 1 plus 1, which is 6. So when x is equal to 1, this relationship is going to plot an ordered pair of 1, 6 on the graph. And we're going to repeat this process for different x values to plot different points on the graph and then connect the dots to get the relationship that we have and plot the equation on the plane. So let's go through a few examples of demonstrating that. So let's say I had the equation y is equal to negative 4x plus 1. So I'm going to have my graph at the ready over here and then label the axes. Almost done. And there we go. So based on what I've shown before this, what I can do is I can construct a table. And in this table, I'm going to have two columns. On the left column will be the x values, and in the right column will be the y values. And then what I'm going to do is just have different slots for different x values and see what I get when I plug them in and evaluate the expression. So if I had x is equal to negative 2, what am I going to get for y? So it's going to be y is equal to negative 4 times negative 2 plus 1. And that gives me a y value of 9. So what this corresponds to is I'm going to have an ordered pair at the point negative 2 comma 9. Now that's a little bit too big for this graph, so I'm not going to be able to graph this one. But if I move on to x is equal to negative 1, then I plug in y is equal to negative 4 times negative 1 plus 1, which gives me a y value of 5. So on the graph, I'm going to have the ordered pair negative 1, 5. That shows up right here. Just about right there. And then moving on, I'm going to say x is equal to 0. So when I plug in 0 here, I'm just left with 1. So it produces the ordered pair 0, 1. And that on the graph is going to be right here. Then if I have x is equal to 1, just plug in 1 to the expression. So I get negative 4 times 1 plus 1, which gives me negative 3. And that ordered pair is going to be right here. And then the last one, I'm going to do x is equal to 2. And when I plug in 2 in for x, what I get for y is a minus 7. So I'll have the ordered pair 2, negative 7 on the graph as well. And that's going to be somewhere quite far down, about right here. And then if I want to graph the entire equation, all I have to do is connect the dots. So it's not the best, but what this equation produces on the plane is a straight line that's going to go through these points. And there's a lot of different ways to graph these equations, but this is the simplest method. It's just plugging in at different x values, seeing what you get for y, and then plot the corresponding ordered pairs. So let's do another example. Let's say that y is equal to x squared plus 2x. So the same kind of thing. I'm going to draw a table, split it up. We have x in one column and y in the other column. And then I'm just going to make some rows that are going to correspond to some ordered pairs on the graph. So if I have x is equal to -2, I would plug in -2 for x and see what I get. So -2 squared is 4, and 2 times -2 is -4. 4 minus 4 gives me 0. So I'm going to have 0 in for the y-coordinate there. Then I'll say x is equal to -1. If I plug in -1, I get -1 squared is 1, minus 2, it's going to give me -1. So I'm going to have the point -1, -1 on the graph. Then if I set x equal to 0, that one's easy, because both of the terms for y have 0, or both of the terms have x's in it, so when I plug in 0 for x, I just get a 0 back. Then if x equals 1, I've got 1 squared plus 2 times 1. That's going to give me 3. And then the last point will be 2. So I'll have 2 squared plus 2 times 2, which is going to give me an 8. Okay, so what I'm going to do now is I have my graph at the ready, and I'm going to count by 2's this time. Just bear with me while I label the axes. So we got -2, -4, -6, -8. Okay, and then now what I'm going to do is plot the ordered pairs that I just found. So -2, 0 is 1. -1, -1 is another point. It's going to be about right here. The origin is a point, so I'll label that. Then 1, 3 is a point. That'll be about right there. And 2, 8 is a point. And that is going to be way up here. And just for the sake of making this look a bit even, if I plug in -3 for x, -3 squared plus 2 times -3 gives me 9 minus 6, which is a positive 3. And then if I plug in x is equal to -4, 2 times -4, this is going to give me 8, or 16 minus 8, which gives me 8. So I'll also have the points -3, 3, and -4, 8 on the graph. So that one goes about right here, and the other one is about right there. And then the last thing that I do is I just connect the dots together. That one, it's kind of bad. Fix that. So you end up with a graph that looks like this when you're dealing with this equation right here. So I hope this video made sense about how to graph equations on the plane using a series of ordered pairs. And this method can get pretty tedious, but if you're really not sure, you can always just try different inputs for x and see what the outputs are, plot the ordered pairs on the plane, and then connect the dots to get the graph of the equation. So I hope this video was helpful, and stay tuned for the next one.